Alright guys, welcome to this channel, and right now we are going to answer a couple of examples with regards to the topic in terms of parallel circuits or parallel connected resistors that is also under DC circuits. So by the way, you can pause the video and answer it on your own, and then let's see how it works. So let's go answer the example number 1. In the circuit below, find the following. A. Total resistance. B. Current flowing on its resistance or resistor. This would be resistor actually. And then a C. The total current. So okay, so let's answer the example number 1. And then the first thing that we need to find is the total resistance. So let's just write solution right there, and then put letter A right here. So total resistance. So since we have a two couple of resistor right here, the formula that we're going to use is just like this. RT would be basically 1 over R1 plus 1 over R2, since we only have R1 and R2, and then raise that by -1. Or we could also use this formula 1 over that is 1 over R1 plus, this is plus 1 over R2. So let's just use this one, substituting the value. 1 over our R1 is this one, we have 50 ohms, plus R2 will be this one, that is 60 ohms, and then let's raise all that up by -1. So putting that into our calculator, the result would be 1 over, that would be 27.27 ohms. 27.27 ohms. So this would be our total resistance. Or let's say if we will have the same outcome when we use this formula, let's have 1 over 50, this is ohms, plus 1 over 60 ohms, and then putting that all into the calculator, and the result is just equal to 27.27. So we have the same outcome right here. So all RT, or the total resistance, or total resistor, will be this one. So let's go to B. Let's put B right here. So we are going to find current flowing on its resistor. So meaning we are going to find I1 and I2. So first thing, I1. So right now we are going to find the parameters that is in relation to R1 in I1, so that we can find the formula. So this time we are going to use the total voltage, so VT. So this would be Ohm's law all over R1, since we already have the value of the VT right here, and also the V1, R1. We are going to find now the I1. So let's put the values. So VT is equals to 220 volts divided by R1, that is 50 ohms. So I'm putting that all into the calculator. We will have I1 is equal to, so that would be 4.4 amperes. So this would be our I1. So we already have I1 right now. The only thing that we need to find in B is I2. So I2, let's put I2 right here. So we can either also use this formula. So we can put V2 right here, or VT, since the voltage is constant, and then also divide that by R2, since we are going to find the current that is flowing to resistance number 2. So putting the values, we have VT is equals to 220 volts divided by, what is our R2? R2 would be 60 ohms. And then putting all that up into a calculator, we are going to have I2 is equal to, that would be 3.67 amperes. So B is done. So let's go to C. Let's put C right here. Okay, the total current, so it's easy. Total current is we just need to add the I1 and I2. So IT is equals to I1 plus I2. So putting all the values, you have 4.4 amperes plus 3.67 amperes. Therefore, we are going to have IT is equal to 8.07 amperes. So that would be our total current. So let's check if we have a correct answer right here. So in terms of IT, we can also use IT is equals to VT over the total resistance, since we have the VT right here and we also have the total resistance. Let's see if we will have the same outcome like this one. So substituting the value, VT will be 220 volts, and then we have RT is equals to 27.27 ohms. Therefore, we will have IT is equal to 8.07 amperes, which is equal to what we have here in the first place. So therefore, this current is correct, this current is correct, and this current also is correct. So that would be for example number 1. Let's go to example number 2. And this is going to be our last example. So you can pause the video and then answer this on your own, and then let's see how it works. So in this resistance, the parallel circuits, we have 3 resistance right here in parallel, and then we need to find the VT since we don't have VT right here, and we need to find I1, I2, I3, or the current that is flowing through each of the resistors. So first, let's find VT. So let's put solution right here. So the solution, and we need to find VT first. So VT, Ohm's law, is just equals to IT, and then RT. Since we only have IT right here, which is the total current, we just substitute that value, 6 amps. And then we don't have the value of RT yet, so since this is in a parallel circuit, okay, we need to find RT first. So let's put right here, RT would be basically in parallel circuits, we just need to find the R1, or the R1 would be this one, R2 would be this one, and R3 would be this one. So let's just put that directly. So we have R1, which is 100 ohms. We need to plus that by R2, which is 60 ohms, and then plus 1 over R3, which is R3 is 85 ohms, and then raise all that up by -1. So you can also use the other formula which we already have used in the example number 1. So putting that up onto a calculator, we will have the total resistance or total resistor of, that would be 26.02 ohms. So this would be our total resistance. So since we already have that, let's just put that value into right here. That's 26.02 ohms. I'm sorry, that is 02 ohms. 02 ohms, and then ohms right here. So since we already have that values, we can now find the total voltage. Putting that up into our calculator, we would have a value of, we will going to have 156.12 volts, or approximately just 156 volts. So this would be our answer. Either of these is or are correct. So we have VT. Right now we're going to find I1, I2, and I3. So the other solution, we need to find I1. So since we already have VT right here, we just need to use Ohm's law. VT is equals I or over R1. We have the value of VT already, and then we also have the value of R1, which is this one. Just putting that up right here, we have VT. Let's use 156 volts all over R1, which is 100 ohms. So we will going to have I1 is equal to, our I1 would be 1.56. The unit would be ampere since this is current. So let's square that up. That would be our I1. So I1, so VT is correct. Check, or I1 is check. Let's need to find I2. We can also use V2 or VT. They are equal, and then over R2. So our VT is 156 volts. This is 156. And then all over R2, which is 60 ohms. So we are going to have is e I2 is equal to, that would be 2.6 amps or 2.6 amperes. So let's square that up. Okay, we already have I1 and we already have I2. We are going to find now the last one, I3. So let's put right here. I3 is equals to VT or V3, since all voltage is constant, and then divided by R3. So substituting all the value, we have 556 volts. We have R3 right here, which is 85 amps. I mean 85 ohms, and then we're going to have I3 is equal to 1.84 ampere. So we already have all that we need to find right here. So let's check if the IT or the total current is equals to I1 plus I2 plus I3. So let's check if we have we're going to have 6 amps right here. So IT I1 we have 1.56 ampere. I2 we have right here 2.6 amps, and in I3 we have right here 1.84 amps. So putting that all into the calculator, we're going to have IT is equal to, that is exactly 6 ampere. So we have 6 ohms also right here. So therefore this one is correct, this one is correct, this one also is correct, and all of these are correct. So that would be for this video. I hope you understand well and then study well, and then if you have a question, please comment down below and I will answer that right away. So that will be it. Thank you so much and God bless.